Welcome. In this session, we will be learning how to conduct tests for diagnostic accuracy in EZR. Over here, we have imported the BR dataset containing the information about best FNAC data which have been categorized according to the Yokohama system. We can first describe it. These are all categorical or ordered categorical variables, and we can just do the frequency distributions for a basic descriptive. Here are our basic descriptives. Once we get the basic descriptives, for the sensitivity and specificity, we have to delete or exclude the inadequate cases. The inadequate cases are totally uninformative. In FNAC, we have to differentiate the inadequate from the indeterminate categories. For example, the atypical is an indeterminate category, but it has got a specific interpretation. It is probably benign. The suspicious category is probably malignant. However, the inadequate category is totally useless and should be excluded for further analysis of sensitivity and specificity. So, how do we do that? We go to the active dataset, go to rows, create subset dataset, include all variables, and we know that Yocnum has in Yocnum we have categorized and numerically coded the data, giving the value of 1 for inadequate, 2 for benign, 3 for atypical, 4 for suspicious, 5 for malignant. So we have to exclude all inadequate cases, that is, all cases coded as 1 in Yocnum. So in the new data set, we will be keeping all cases which are greater than 1. So 2, 3, 4, 5. And let us name the new data set, say BR1. Here we have this. We have created a BR1 dataset. We can always check the data again. They have the same variables. But here we see that there are no inadequate cases. And in Yocnum, it starts from 2, 3, 4, 5. 2 is benign, 3 is atypical, 4 is suspicious, 5 is malignant. So, how do we check out the sensitivity and specificity? First, let us take the example of the cases which have been coded just as benign or malignant, the simple 2 by 2 case, and then we will proceed further. For benign and malignant, we first do a cross tabulation. Cross tabulation get into discrete variables and get into the create two-way table and compare two proportions by Fisher's exact test. We can keep this take the Fisher exact test, but we can also exclude it because we just need the cross tabulations. We're going to exclude this. The thing is, FNAC 2 tier we're using as the row variable. HCAT, mind you, HCAT is the biopsy diagnosis. 0 is benign, 1 is malignant. We are not going to need any percentages right now. We're just going to see what the cross tabulation is. And here we have it. For benign cases, 44 of the 44 cases which were diagnosed as benign on FNAC were benign on biopsy as well. However, 4 cases which were diagnosed as benign on FNAC turned out to be malignant. For the malignant cases which were diagnosed on FNAC, which were given a category malignant, none of the cases turned out to be benign on biopsy. But 195, all 195 of the malignant cases diagnosed on FNAC turned out to be malignant. One is malignant, one on HCAT is malignant. So, from here we have to get to the sensitivity specificity table. We get into the statistical analysis, accuracy of diagnostic test. we get into the accuracy of qualitative test. Now we get a different type of table. Disease positive, test positive. This test is FNAC, what we are testing. Disease positive is the actual diagnosis, in our case, the biopsy. Now, test positive for malignancy and disease positive. The top left cell actually corresponds to the bottom right cell over here. We are trying to diagnose malignancy. Malignant cases are those which are positive for disease. Which is positive for disease, test positive, and disease positive is actually this 195. Yeah. Positive for disease, that is biopsy category HCAT1 malignancy, but negative by the test, that is put as benign by the test. This is 4. Check it out. This was positive on biopsy, but negative on FNAC. Put it as 4. Positive by the test, by FNAC, negative on biopsy. We did not get any such case. This is 0 over here. And negative by the test, that is benign on FNAC, and negative for the disease, that is 44. Just fill in the cells like this, press OK, and here we get the point estimates with the 95% confidence intervals. We confirm the table over here. What we are specifically interested in over here are the sensitivity, specificity, positive predictive value, negative predictive value, of which the sensitivity and specificity are prevalence independent parameters, and that's why they are the most important. This is the estimate of sensitivity 0.98 or 98%. This is the estimate of specificity 1 or 100%. But we are not just interested in the point estimates. For interpretation, we have to look at the confidence intervals, specifically the lower and upper confidence intervals. The lower confidence interval for sensitivity is 0.949 or 94.9%. Is that high enough? If you take a cutoff of 90% as good enough, this is good enough. However, if you take a cutoff of 95%, maybe it is not good enough. We cannot prove that it is good enough as yet. Let's see the specificity. Even though the specificity is 100%, the lower confidence interval is only 0.882. The upper confidence interval is 100%, but the lower confidence interval is 0.882, that is 88.2%. That is, we cannot be absolutely certain, given this experiment, given this data, that the specificity is very high. Okay, we can only have a lower limit of 88.2%. If we take a, if we want to prove that it is greater than 90%, can we do so? No, we can't, given this data. However, if our acceptable range is say 85%, then yes, this shows that this method is specific enough. Now, FNAC is just not about benign and malignant diagnosis. We also have the atypical or probably benign category and suspicious or probably malignant category. Suspicious of malignancy is probably malignant. How do we include that information? Will that make any change? Let us see what the cross tabulation is. Create one-way table, compare two proportions. We have kept the Fisher's exact test unticked, and we are using Yochnam. And the columns is HCAT. Let's see what the numbers are right now. Okay. So we get Yochnam 2, 3, 4, 5. Now, once we have this, we can always say that what is the benign category? How will we take the cutoff? We can either take just the benign as benign, that is, Yochnam is equal to 2, just the benign category as benign, and the rest as malignant. Or we can take the benign and probably benign categories as benign, this Yochnam 2 and Yochnam 3. That will give rise to a separate set of sensitivity and specificity. Or maybe we may be very, very conservative for the diagnosis of malignancy and treat even the suspicious category as benign, that is Yognum 2, benign, atypical, and Yognum 4, suspicious of category, suspicious of malignancy category as benign, and just the malignant category as malignant. So, in order to do that, we need to do three different sensitivity specificity analysis, diagnostic accuracy analysis. How do we go about it? One of the easy ways to go about it is to create three more variables. For example, over here, we use bin numeric variable with a specified threshold. Select Yognum, which we are going to threshold. And let us say, considering atypical or greater than atypical as malignant. So, equal to or greater than threshold, put it as 3. New variable name, let us put as atyp plus, that is atypical plus is malignant. We get it? We have created a variable atyp plus. We can always check out whether we have done it correctly or not by another cross tabulation. Okay, atyp plus and Yognum. And what we see over here is atyp plus is equal to 0 corresponds just to Yognum 2, that is benign. 48 cases of benign, and all the cases which were categorized as 1 has been categorized are represented by what were originally reported as atypical or suspicious or malignant. So we have at a predefined cutoff of atypical, we are treating as malignant over here. Another thing we can do is we can subset it according to taking the threshold of suspicious as malignant. So let us bin numeric variable with the threshold Yognum equal to or greater than 4, that is suspicious, we are only treating as malignant. Let us make it sus plus, that is suspicious plus. Okay, we can also confirm it by the same way, by the cross tabulation. And as we see, sus plus is equal to 0 includes the benign and atypical categories. Sus plus 1 includes the suspicious and malignant categories. A third threshold data would be we are taking just the malignant cases as malignant. Let us again do the same thing, variables, bin numeric variable with specified threshold, put it as mal plus equal to or greater than 5. Sorry, right. Made this, again confirm it. This is, and over here we see mal plus 0, that is in this variable 0 corresponds to the benign, atypical, and suspicious categories, and just the malignant category is given a coding of 1. Now we should be calculating the sensitivity and specificity of these three thresholds. So for this, we need to find the cross tabulation with the histopathological diagnosis, the reference standard. Let's do with atyp plus first. Always The row variable would be the test, column variable will be the reference, we don't need any percentages over here. Let us do this. We have got it over here. 80 plus 0, 44, H cat 0, H cat 1 is malignant 4, and for 80 plus 1, 30, 221. Now let us get into the sensitivity specificity analysis, accuracy of diagnostic test, accuracy of qualitative test. What is disease positive and test positive? This is actually what is positive for the test over here, 1, and biopsy 1, 221. What is test positive but actual disease negative? Test positive but actual disease negative is 30 in this case. Test negative but actual disease positive, it is 4 in this case. And test negative, actually negative, 44. Let's see. And we get the sensitivity and specificity around here. The sensitivity is, again, you see over here, the sensitivity for this category is higher than what we got earlier of 98%. The lower confidence interval is now 95.5%. However, if we take this threshold, the specificity suffers a lot. The specificity is only around 59.5%, with a lower confidence interval going below 50%. So this threshold is highly sensitive but not specific enough. Let us see about a threshold where we take the suspicious and malignant categories as malignant. We do the cross tabulation. Instead of 80 plus, use sus plus over here. No percentages. We get these numbers. Now let us feed this into the sensitivity specificity table. Accuracy of qualitative tests from accuracy of diagnostic test. Now, disease positive, test positive. This is this 216, 216. Now, test positive, disease negative. So this is test positive. This is disease negative 6. Test negative, disease positive. This is test negative. This is disease positive. Over here it is 9. And test negative, disease negative, this is 68. Let's see what the sensitivity specificity threshold tells us about over here. As we see, as the threshold went up, the sensitivity actually went down to 96% from 98.2. The lower confidence interval went down. It is still higher than 90%, but it has gone down. The specificity, on the other hand, has increased markedly. It has gone up to 91.9% with a lower confidence interval of 0.832. And check it out, the one of the big measures of accuracy is sensitivity plus specificity minus 1, which is also known as Youdin's J. Sensitivity and specificity, that sum is higher for this threshold than the threshold which was given earlier, where the threshold was just atypical and above. Possibly this is a better threshold for overall accuracy. Now let us find out the sensitivity and specificity for using the only the malignant as a malignant on all others as benign. So that would be mal plus over here. Column variable is still remaining the reference standard, the biopsy. And over here we get these set of numbers. Now let us feed it into for the accuracy of diagnostic test, accuracy of qualitative test, test positive, disease positive. That is test positive FN, this mal plus is equal to 1, this positive, and disease positive, that is 195 over here. Test positive, disease negative. Test positive, disease negative is 0. Test negative, disease positive. This is 30 out here. And test negative, disease negative in this case is 74. Let's do it. We see the sensitivity has gone down even further. If we take this threshold, we realize that the sensitivity will go down markedly, but the specificity has gone up markedly. It's 100% with a lower confidence interval of 92.8%. That means this is higher than, we can very, very confidently say that the test, that the specificity at this threshold is higher than 90%, possibly accurate enough for specificity over here. Okay, what we notice? We notice that as the threshold goes up, this was the uh, thing for 80 plus. Over here, the sensitivity was very high, the specificity was low. As the threshold increases, the sensitivity goes down, the specificity increases. At the highest threshold, the sensitivity goes down even further and the specificity reaches its maximum value. So we should be taking all these three. From these three over here, I can come to the conclusion that for high sensitivity, for picking up cases, a threshold of atypical possibly is the best. For very high specificity, a threshold of malignant is possibly the best. If we have to have a combination of sensitivity and specificity, a threshold of suspicious is possibly the best. Now, we can get these three thresholds. What about the overall accuracy? For the overall accuracy, we can do what is known as the ROC curve analysis. Get into the statistical analysis, accuracy of diagnostic test, and we can do the ROC curve analysis from here. But that will be kept for a next class. Thank you.